Hi, this is Joe from the Math Perimeter. In this video, we will compute the partial derivatives of f of xy equals x squared y plus y cubed, f of xy equals e of x squared plus y squared, f of xy equals x sine of x squared plus y squared, and f of xy equals x over x plus y. To begin, we find the partial derivatives of f of xy equals x squared y plus y cubed. We first find the partial derivative with respect to x. To begin, we apply the sum rule to obtain f sub x equals d by dx of x squared y plus d by dx of y cubed. Applying the constant rule, we get f sub x equals y d by dx of x squared plus d by dx of y cubed. Differentiating, we obtain f sub x equals y times 2x plus 0. Multiplying, we get f sub x equals 2xy plus 0. Adding, we arrive at a final answer of f sub x equals 2xy. Next, we find the partial derivative with respect to y. We begin by applying the sum rule to obtain f sub y equals d by dy of x squared y plus d by dy of y cubed. Applying the constant multiple rule then gives f sub y equals x squared d by dy of y plus d by dy of y cubed. Differentiating, we obtain f sub y equals x squared times 1 plus 3y squared. Multiplying, we arrive at a final answer of f sub y equals x squared plus 3y squared. Next, we find the partial derivatives of f of xy equals e of x squared plus y squared. We first determine the partial derivative with respect to x. To begin, we apply the chain rule to obtain f sub x equals e of x squared plus y squared times d by dx of x squared plus y squared. Applying the sum rule then gives f sub x equals e of x squared plus y squared times d by dx of x squared plus d by dx of y squared. Differentiating then gives f sub x equals e of x squared plus y squared times 2x plus 0. Adding, we obtain f sub x equals e of x squared plus y squared times 2x. Multiplying, we arrive at a final answer of f sub x equals 2x times e of x squared plus y squared. Next, we determine the partial derivative with respect to y. We begin by applying the chain rule to get f sub y equals e of x squared plus y squared times d by dy of x squared plus y squared. Next, we apply the sum rule to obtain f sub y equals e of x squared plus y squared times d by dy of x squared plus d by dy of y squared. Differentiating, we obtain f sub y equals e of x squared plus y squared times 0 plus 2y. Adding, we get f sub y equals e of x squared plus y squared times 2y. Multiplying, we arrive at a final answer of f sub y equals 2y e of x squared plus y squared. Next, we determine the partial derivatives of f of xy equals x sine of x squared plus y squared. We begin by finding the derivative with respect to x. To begin, we apply the product rule to get f sub x equals sine of x squared plus y squared d by dx of x plus x d by dx of sine of x squared plus y squared. Applying the chain rule then gives f sub x equals sine of x squared plus y squared d by dx of x plus x cosine of x squared plus y squared d by dx of x squared plus y squared. Applying the sum rule then gives f sub x equals sine of x squared plus y squared, d by dx of x plus x cosine of x squared plus y squared times d by dx of x squared plus d by dx of y squared. Differentiating then gives f sub x equals sine of x squared plus y squared times 1 plus x cosine of x squared plus y squared times 2x plus 0. Adding then gives f sub x equals sine of x squared plus y squared times 1 plus x cosine of x squared plus y squared times 2x. Multiplying, we arrive at a final answer of f sub x equals sine of x squared plus y squared plus 2x squared cosine of x squared plus y squared. Next, we take the partial derivative with respect to y. Applying the constant multiple rule gives f sub y equals x d by dy of sine of x squared plus y squared. Applying the chain rule, we get f sub y equals x cosine of x squared plus y squared times d by dy of x squared plus y squared. Applying the sum rule, we obtain f sub y equals x cosine of x squared plus y squared times d by dy of x squared plus d by dy of y squared. Differentiating, we obtain f sub y equals x cosine of x squared plus y squared times 0 plus 2y. Adding, we obtain f sub y equals x cosine of x squared plus y squared times 2y. Multiplying, we arrive at a final answer of f sub y equals 2xy cosine of x squared plus y squared. Next, we find the partial derivatives of f of xy equals x over x plus y. We begin by finding the partial derivative with respect to x. Applying the quotient rule gives f sub x equals x plus y times d by dx of x minus x d by dx of x plus y all over x plus y squared. Applying the sum rule, we get f sub x equals x plus y d by dx of x minus x times d by dx of x plus d by dx of y all over x plus y squared. Taking the derivatives, we obtain f sub x equals x plus y times 1 minus x times 1 plus 0 all over x plus y squared. Adding, we get f sub x equals x plus y times 1 minus x times 1 all over x plus y squared. Multiplying then gives f sub x equals x plus y minus x all over x plus y squared. Subtracting, we arrive at a final answer of f sub x equals y over x plus y squared. Next, we find the partial derivative with respect to y. Applying exponential properties, we obtain f sub y equals d by dy of x times x plus y to the negative 1. Applying the constant multiple rule then gives f sub y equals x d by dy of x plus y to the negative 1. Applying the chain rule then gives f sub y equals negative x times x plus y to the negative 2 d by dy of x plus y. Applying the sum rule then gives f sub y equals negative x times x plus y to the negative 2 times d by dy of x plus d by dy of y. Taking the derivatives, we obtain f sub y equals negative x times x plus y to the negative 2 times 0 plus 1. Adding, we obtain f sub y equals negative x times x plus y to the negative 2 times 1. Multiplying, we obtain f sub y equals negative x times x plus y to the negative 2. Applying exponential properties, we arrive at a final answer of f sub y equals negative x over x plus y squared. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.